So today's lesson is going to be called concavity and the second derivative.
What?
Concavity. Hold on a second.
I can't wait.
Nate first.
Nate first.
See, I'm not even really here. I'm so exhausted. So, Michael, can you be on extra double alert today for errors? Okay, so here we go. Who please do this? Okay, so from Monday and I guess Tuesday too, what does the first derivative tell us about a graph? The slope, okay? So what we said was on the graph, we said if f prime of x is greater than 0. What does that tell you if f prime of x is greater than 0? Yeah, it's going upwards. So the graph's going to look something like this, okay? It's going to be upwards in that direction, right? If f prime of x is less than 0, what's going to happen? And again, so our first derivative is going to be our slope. Okay, that's what our first derivative tells us. We're going to deal also with the second derivative, okay? So today the second derivative is going to be f double prime of x is going to be the rate of change of slope. I'm going to make a little tiny chart here. Okay, we're going to make a little tiny chart here if you don't mind. There's going to be 4 entries here, okay? Let's go here, guys, please. Okay, so let's just do a little interval chart there. There's going to be 12 4 by 3, okay, if you don't mind. The first thing that I'm going to say is that I'm going to have a positive slope. Okay? So positive slope, we already said, is going to be looking like this. And I'm going to say also f double prime of x is positive. What does that mean then? So if the rate of change of slope is increasing, what does that mean? So go ahead. Getting steeper. So what does the graph that's getting steeper as you go along look like? Yeah, exponential. Okay, good. So this one's going to look something like this. Okay, so you're going to have a graph that starts off with a positive slope, but it's getting more and more positive. Right? In the same way then, if I have a positive slope, but it's going to be negative, so what does that mean? So Brother than Joel here, because I know you got this. Somebody else here, please. What does that mean if you're going to have a positive slope? Yeah, good, Evan. Okay, so it's a positive slope that's getting more negative. He did the hand signals and the instead of the talking, but it's going to be a positive slope that's getting more negative. Okay, so more or less positive slope is going to look something like this. Okay. All right, so an example of a graph with that would be what, logarithms, sort of, or negative logarithms would be like that. Okay, we'll look something like that. We'll get to that in a little bit. Okay, now, here's the next question. What does a negative graph that's getting more positive look like? What does a negative slope that's getting more positive look like? Yeah, it's going to be sort of like this. Okay, now, if you're saying, I don't know why this is the case, please ask here, okay? The idea was this is like just plain negative. If it's getting plus would be less negative, right? So it's getting more positive, more towards 0. This is 0 like this. And then finally, a negative graph that's getting more negative is going to start like this and get really, really negative like that. Okay? So that's what the second derivative tells us. We will be using the first and the second derivative to graph every single function from here on out. Today we're doing polynomials. Monday we're getting to rationals. And I think that's all we're doing in this unit. Is we're going to get the word problems and stuff like that later on after that. Okay, so this is sort of the first of the tricky stuff. Mondays and Tuesdays lessons built us for today. You got a little sun, right? Sorry.
I know.
Just statement obvious. Here we go. Example 1 says, actually before I start with example 1, does everyone get the fundamental concepts I'm doing here? You get that? because this is going to give us the shape of our graph quite nicely. Example 1 says, sketch the graph. Of f of x equals x cubed minus 3x squared minus 9x plus 10 using calculus. All right, I'm going to go through exactly what using calculus means here in a sec, right? Yes. Okay, these are the things we're looking for. I'll write this in solution. I'm going to start with my domain. Finally. Okay, we're finally here. This is good. What's the domain of this graph going to be, please? This is a cubic graph. What's the domain of something that's cubic going to be? Not Michael. What's the domain of something that's cubic? Go ahead. Anything. Domain is anything. And as we get to more and more complicated graphs, and again, if you're in Mr. Lacey's class, this is the similar steps to what he did last year. Next is going to be intercepts. And it's just actually going to be the y-intercept is all we're going to use.
For the domain and range, do you care if people use interval notation?
Yeah, as long as I can make out what it is. Yeah. So I know Mr. Kemp, the way Mr. Kemp does it, is he does like this, right?
That would be square bracket.
Round bracket, and you lose half marks for that.
Yeah, do my way. That's why I'm not in Mr. Kemp's class. All right, what is my y-intercept for this graph? Someone other than Evan. Because Evan's in the zone. So go ahead. 0 and 10. Good. Asymptotes. You're probably saying, Mr. Sutherland, why do you talk about asymptotes? Because this same formula that we're using today, we can use for any type of equation that you're ever going to see. Okay. What are the asymptotes for a cubic graph? Oh goodness, you guys are freezing. What's an asymptote again?
Gaps in the graph.
It's one very good, excellent. So is there anything like that on a cubic graph? No. Generally, what causes an asymptote? Yeah, like when you divide by 0, that's generally what they are. And again, there's horizontal ones too that exist. Then we get to logs, which we will in the next unit. Okay, so that's not. Now, I'm going to hit pause in the video for a sec so I can whisper. I know as soon as I say this, time is not there. Okay. All right, then we're going to find, after that, we're going to find critical points.
And Mr. Kemp did.
Oh, I did? I'm not.
Mr. Kemp said, Mr. Kemp yeah.
We'll leave that, we're going to leave that this article. That's the critical points. Okay, so what critical points are going to be, actually I probably should have said this. When you solve f prime of x is equal to 0, what does that give you again? No, that's f of x equal to 0 new roots. These are going to be local max and local min, right?
Doesn't that include the ones that are local maximum? Doesn't that include the ones that are like...
Yeah. So like, for what would happen if this graph looked like this? F prime of x equals 0 would give you this and this. Okay?
Or it could give you like a cubic area, like squiggle.
Yeah, so just
Quantum inflection.
what's that?
Like the quantum inflection.
Yeah, that's the next one. So f double prime of x gives you a point of inflection.
So then f prime of x can give you just x cubed.
Yeah, we'll talk about that. It's just not confusing it quite yet, okay? So what a point of inflection is going to be, if you take a look right there and right there, okay, all of a sudden we have a graph that's negative getting more negative. When you get to this red x point here, it's negative but it's getting more positive. Okay, so see the shape of the graph goes from looking like this, and then going over and looking like that. And the same thing here then, right? Actually, that's probably not a point of inflection at the end, I wouldn't think. Let's get rid of that, okay? Because this, again, would be increasing the whole way up then, right? So you get the logic there, right? So you're going from curving like this, and then once you get that point, you're curving like this. Yeah, go ahead.
Is it one at double prime by 0?
Right. Thank you. My thing, not in there to save me. I was joking. So yeah, this is when f double prime of x equals 0. So what you'll be solving here is you'll be solving f prime of x is equal. You'll be solving f prime of x equal to 0 and f double prime of x is equal to 0. So that's what I'd like you to do right now for me. Okay? So find the critical points. We'll do the interval chart here in a sec. So you're going to find f prime of x equal to 0, f double prime of x equal to 0, and then go to town.